Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, February 19th, 2021. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on a wintry evening in Rockport, Massachusetts. These Earth and Space Reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our human relations with Earth's life-sustaining environment, and who wonder about the greater cosmos, including our place in space and moment in time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. Today, we are joined by members of the Rockport Research Explorers, Rockport Cultural Council, and other curious folk. Thank you for coming. Our special guest for this evening is Ms. Emily Dailey from San Diego. She is a 2015 graduate of Rockport High School who has gone on to pursue many exciting adventures in the fields of marine biology, environmental conservation, and science education. In my letter of recommendation for Emily back in 2014, I noted that despite being the only girl in my physics class, she managed to remain upbeat, engaged, and unbowed. Her multicolored notes are incredible. I could frame them, unquote. I also noted, quote, she is especially interested in law and government. She is fascinated by rules, their diverse uses and effects, unquote. To my surprise, Emily has since taken an altogether different trajectory, one that has her aboard sailing vessels plying the seas or onshore in maritime locales that teem with wildlife. So Emily, welcome to our little gathering.
Thanks for having me.
Very good. Before you share with us your aquatic travelogue, could you please tell us how you left law and government, you left it behind, and became an oceanic explorer instead?
Yeah, so when I graduated from RHS in 2015, I definitely had some interest in environmental science. I always worked at the Gloucester Museum School Project Adventure Camp, if any of y'all are familiar with that. And so I had been doing experiential education teaching for a while in a more informal sense. But I sort of felt like I had to leave that behind. Being a camp counselor forever didn't really seem like a viable trajectory. And I wasn't necessarily interested in kind of what I saw as being a scientist, being in a lab and doing boring experiments all day. And so that was kind of the concept that I had in mind when I went into university as far as what it meant to be a scientist. And so I was kind of pushing against that. And I originally, when I thought I was going to pursue law, was interested in environmental law. But those classes just weren't super interesting to me. And so I kind of bounced around. I was a biology major for a while. I thought I was going to be a psych major for a while. And then eventually I just kind of landed on environmental science because that seemed like the most fun. And I didn't know exactly what that meant for me. But when I switched to environmental science, it made sense all of a sudden for me to do C semester, which now that I work at C semester, I realize that I probably could have done it with any major, but that made it seem a lot more applicable. And so that was pretty exciting because C semester was something that I had always wanted to do. So in the eyes of my Florida State advisors, it made a lot more sense as an environmental science major. So that's kind of how that trajectory went. I haven't entirely left law behind. There's always the possibility that I would do some sort of a science policy PhD program, but becoming an attorney is probably not in the cards anymore.
Right, not like your mother.
Yeah, exactly. Not that I wouldn't want to be just like my mom. She's a wonderful woman. All right.
Very good. Well, you're welcome to share your slides, and we'll take it from there.
All right.
Here you go.
Great. Okay, so my presentation today is titled Sailing for Science, Experiential Education on the High Seas. So I'm going to be talking about my experience working at Sea Education Association, or as you might know it, Sea Semester, which I will, from the beginning, differentiate from semester at sea, which you may also have heard of. Semester at Sea is a program that's on a cruise ship that goes to like 12 countries. That is not where I work. That's not what I do. So if that's your mental picture, get that out of your head. That's not it. This little boat right here actually isn't that little. This boat is about 134 feet. It's a ship. It's a brigantine rigged tall ship. It's the Korath Kramer, based out of Woods Hole, Massachusetts. And in the background, you can see the Block Island Wind Farm off the coast of Rhode Island, which makes the boat look pretty small, but those turbines are actually really, really large. So the boat is not small. It can fit 40 people sleeping on it at any given time, and it's capable of oceanic journeys. And so at Sea Semester, we bring undergraduate students to sea for periods of up to 6 weeks on what would legally be termed the high seas, international waters. And so that's where I work. And so I'm going to talk about that today. The format of my presentation, I have written notes and I have it in sort of a formal structure, but if people have questions, feel free to turn your microphones on and jump in at any time, because I'm not necessarily sure what parts of this are interesting to all of y'all. Now that I see that there's some younger students on the call, maybe y'all might be interested in being students. And so if you have questions about Sea Semester as it pertains to you, rather than as it pertains to me as my workplace, feel free to jump on. I'm happy to answer those questions on this presentation. Okay, so like Dr. Weller said, I was a Rockport High School student, and as I said, I worked at the Gloucester Museum School Project Adventure Camp during my time at Rockport High School and a little bit after. And this was kind of my first brush with experiential education. So in these photos, you can see some students who are probably all around high school age now. So you might even know some of these students. But at GMS, we would basically go to interesting places in our backyard right on Cape Ann. So the left photo is taken at Red Rocks in Gloucester off of 133 or 128. And the two right photos are at Rafe's Chasm, which is also in Gloucester. We would spend a lot of time at Halibut Point. So we spend a little bit of time in Rockport, but these are all places that we're familiar with. And basically the concept of this camp was to take campers to a cool place and hang out and allow them to develop their own questions. And the required reading for being a counselor at GMS was Rachel Carson's The Sense of Wonder, which is a short book that kind of talks about children's natural curiosity. And that's what we tried to culture at GMS. We would, bring students to a place where there were some cool rocks, and then undoubtedly the students would ask questions about the rocks, and we would end up with a really interesting discussion about geology and local history. And I always found this version of teaching to be really compelling. I just didn't necessarily have an image for how I could make it my career at the time of graduating from Rockport High School and working at GMS. So when I started school at Florida State University in 2015, like I said, I bounced around a fair bit with majors, and my time at SCA is really kind of what solidified, okay, environmental science is something that I can do and I can make a career out of. And so I have future plans with this that don't just include being on tall ships working at SCA, but that's what I'm going to talk about today. So Sea Education Association is, in a nutshell, a study abroad organization in which undergraduate students take classes in biology, oceanography, nautical science, policy, and some humanities during both a short component in Woods Hole, Massachusetts, and at sea aboard one of our two tall ships. So we have the Korath Kramer and we have the Robert C. Seamans, and they're very similar in a lot of ways. They're both 134-foot brigantine rigged tall ships. But I'm going to read you SCA's mission statement because I think it sort of gets to the core of our goals here better than I can, and in a more coherent way. So SCA is a global teaching, learning, and research community dedicated to the exploration, understanding, and stewardship of marine and maritime environments. SCA empowers students with life-changing sea voyages of scientific and cultural discovery, academic rigor, and personal growth. Our Sea Semester program features an interdisciplinary curriculum and dynamic leadership development experience at sea, aboard tall ships, and on shore. And so SCA is kind of the the more grown-up version of the GMS camp that I worked at and attended during my time on Cape Ann as a kid. So I like to say that I just kind of leveled up and moved offshore. So now I'm doing a very, very similar thing on ships, bringing students to a really unfamiliar place and allowing them to ask questions based on what we find. SCA is accredited through Boston University, and so the logistics of it are basically the students from all over the US and even all over the world. We always have a few international students on every trip come to our campus in Woods Hole, and they take some classes, and then they go to sea on board our 2 tall ships in a group of about anywhere from like 10 to 24, depending on how particularly popular that program is. But yeah, I'm going to talk a little bit more about our campus in Woods Hole. So if you've heard of Woods Hole, you may have just gone on vacation there. All of you guys live in Massachusetts. But if you've heard of it and you haven't been there, the reason why might be because you've heard of the Woods Hole Institution, a world-renowned research and teaching, a little bit of teaching institution in oceanography. But Woods Hole is actually unique because there are 6, well, depending on what there's some smaller institutions as well, but there are 6 large educational institutions that are all focused on marine and earth science in a really small area. Woods Hole is a village in a town of Falmouth. So I feel like Falmouth is like the size of Gloucester, and Woods Hole might be a little bit smaller than Rockport. So it's a really small space to have a lot of thoughtful scientists. But you have the Woods Hole Oceanographic Institution, you have the Marine Biological Laboratory, which is affiliated with the University of Chicago. You've got the USGS, the US Geological Survey. You've got the Woods Hole Research Center, and you've got Sea Education Association, so where I work. And that's pretty unique for our students when they're on shore in Woods Hole, because we have access not only to those really interesting researchers who work at all of those institutions who can just come in lunch break and give a talk that otherwise you might only see at a national conference, but also because we can literally use the resources of those institutions. So although we're not technically accredited through WHOI, Woods Hole Oceanographic Institution, we can use their property. So we have access to their library as well as their online library. So all of their journals, which is something that SCA wouldn't be able to offer if it were in a different physical location, just because it's a relatively small nonprofit institution. We also keep one of our vessels, the Korath Kramer, on Woods Hole property for a good chunk of the year in the summertime. So if you've ever seen a tall ship in Woods Hole, it probably was the Korath Kramer. So that's kind of what our shore component, those are the perks of our shore component. Students spend anywhere from 2 to 6 weeks there in Woods Hole on a pretty intense high school style schedule. So you go to college and you get used to having, a couple classes in the morning and like maybe something in the afternoon, and the rest of your day is for whatever you want. And that's not the style at Sea Semester. You have class from 8 to 4 every day, 5 days a week, and plenty of homework. So it's not like it's all just happening in the classroom. It's a really intense experience, but that's super intentional because our semester programs are really only 12 or 13 weeks in length in total. And then you're cramming a lot of that academic component into that short component. And we need to set up students with a lot of skills so that they can be successful, both with their academic goals at sea, as well as their kind of more personalized research goals. And we also try to outfit them with some sailing skills before they get on the boat. So the short component is really intense, but it's a cool place to be in a pretty cool environment of a lot of interesting scientists. And then the campus that everyone cares a lot more about are the 2 ships. So on the top left, you've got the Robert C. Seamans. Actually, both of the top photos are of the Robert C. Seamans. That's our Pacific vessel. And it operates largely in the South Pacific Ocean. So we spend about half of our year in New Zealand, and then we bounce around to Fiji, Samoa, Hawaii. Right now we're in California, which is sort of a funny thing that's more because of COVID rather than because of a particular cruise track. But over the next few months, we'll be offering cruise tracks out of California. So if that's something you're interested in, we will be in and out of San Diego for about the next 6 months. And then on the bottom, we have the Korath Kramer, which is our vessel that operates mostly in the Atlantic. So we're up in the North Atlantic for a lot of the year, and then we head down through the Sargasso Sea in the fall. We spend the summer in the Caribbean, and then we head back north in the spring, back through the Sargasso Sea. And so different programs that sort of line up with, we have like a coral reef expedition that's going to happen in the Caribbean, whereas some of our programs that need larger oceanographic spatial arrays are going to happen on those longer cruise tracks from, Massachusetts or Maine down to the Caribbean. So those are the areas that our ships encompass. You notice that from the outside, they look pretty similar. They're both two-masted because they're brigantine rigged. So they have fore and aft sails. So if you think of a boat, like you have the front of the boat here and the stern over here, fore and aft sails kind of stay in that same plane, whereas squaresails are perpendicular to that plane. And so a brigantine rigged ship is one that has squaresails on the forward mast. So it's kind of a cool rig because it has some of the more traditional elements of tall ship sailing. Those squaresails require a lot more effort than fore and aft sails do. So if you're familiar with schooners don't have squaresails. So the Lannon and the Adventure, boats that y'all might be more familiar with being from Cape Ann, our boats are somewhat similar, but they have some differences too. And they make up campus. So you get on this boat and sometimes you're going to be on it for 6 weeks straight. I just ran a program like that a couple months ago. We didn't stop on shore one time. And sometimes you'll be kind of bopping around to different islands. So it just depends on the cruise track, but that's what the ships look like. So I'm going to talk a little bit about the logistics of life at sea. So with any of our programs, we're always going to be on a watch schedule. And so the way this works is all of our students get split into 3 different watches. We have A watch, B watch, and C watch. And then each of those groups, which will be 4 to 8 students, stand with both a mate and a scientist. So a mate has a license. They work underneath the captain, and their job is the safety of the ship, the navigation of the ship, setting and striking sails, and teaching students about that. And then my job is as an assistant scientist. So I work with the mate to teach students about how to do oceanographic deployments. And I do a little bit of mentoring on their long-term research projects, which we'll talk a little bit more about. But our boats sail for science. So we can't do our science without the students learning how to sail and getting the boat from point A to point B, because we're often trying to sample at very specific either geographical locations, or just we're trying to get to a particular oceanographic province. And so it's really important that our students learn how to sail as quickly as possible so that we can do our science. But then it's also really important that our students, learn the logistics of deploying instruments and processing our samples, because once we get to that spot, we want to be able to do all of our science fairly quickly. So it's a pretty crazy learning experience your first 2 weeks at sea. You're just going to be basically learning. You're just going to we always use the metaphor that we're kind of throwing spaghetti at a wall and seeing what sticks. And the goal is that different things will stick with different students. But that first 2 weeks is pretty overwhelming, because for the first time, students are, working for 6 hours, and then they're asleep for 12, and then they're awake for 6 hours, and then they're asleep for 12. So you're not on a normal sleep schedule. You might have watch from 1 in the morning until 7 in the morning. And then you would have watch again the next day, just after lunch at 1300. So it's a pretty wild life, but our students get used to it pretty quickly. And then after they start to kind of learn the ropes, learn the lines, weeks 2 through 4 are focused mostly on kind of seeing all the things that so me as the assistant scientist and the mate, were doing behind the scenes. So, at the beginning, I might say, okay, can you go out on deck and, set up this net? I'll be out to help you. And then the next 2 weeks, I'll say, okay, go set up that net. You know how to do that at this point. And then the last 2 weeks, this is kind of that leadership and growth component. We have our JWO, JLO phase, and that's when students have learned how to sail. They've learned how to do the science that we do. And they take a lot of ownership in that, and we kind of go hands off as the watch officers. So that's kind of how the progression of the trip goes, as far as like what we expect from students. Basically more every single day, but there are some clear cutoff points every 2 weeks. Yeah, that's kind of how life at sea works. And I've kind of referenced deck in science. Those are the kind of the ways that we split students up, and they're the main components of your time at sea. You're either going to be out on deck, setting sails, navigating, at the helm, at forward lookout, or you're going to be in science with me. And when we're in science, we're doing oceanographic deployments, just like any other research boat that you may be familiar with. So we have some pretty serious equipment on board. We're not just throwing a net in the water and calling it science. We have some pretty serious oceanographic equipment that's just scaled down for the size of our ship. So a lot of the brands that we use for our equipment are the same as what you'd see on like a Hui ship or a University of Washington research vessel. Pretty similar stuff. Okay, I'm going to briefly talk about nautical science, because technically it is science and this is a science presentation, but keep in mind that this is not necessarily my wheelhouse. This isn't what I teach. So this is what the mate would teach when students, or so the captain would teach when the students were on shore, and what the mate would teach once the students were at sea. And so navigation is a huge part of any journey, particularly our long ocean passages. So for example, on my student trip, we sailed from Christchurch, New Zealand, all the way to Papeete on Tahiti in French Polynesia, which is it ended up being about a 4,400 nautical mile journey. And so there's a lot of opportunities to get lost. And navigation is the first thing that you learn during your shore component. You're going to start looking at nautical charts, learning how to plot GPS positions. As time goes on, you're going to learn what's called dead reckoning navigation. So the students basically, we get a GPS position at, let's say, noon, and then we know that for the next hour we sailed north, and then we know the speed that we were sailing, and we kind of estimate where we would be based on that. And so we do that for several hours, and students can get pretty effective at their dead reckoning skills. At that point, we then upgrade to the serious navigation, the more traditional navigation, which is celestial navigation. And so in the background, you can see an outline of one of my friends who has a sextant. And so basically she is taking a line of position using a star. So she knows where the star is in the sky. She knows the day of the year, and she's calculating the angle between the star and the horizon. And then we kind of triangulate our position using three or more of those. And so that's a pretty cool scientific thing that happens, not technically in the science department, but very much is scientific, and is a cool thing to learn about as a student and also as a scientist when I have a chance to get out on deck. Another huge part of being out on deck in nautical science is the meteorology that students learn about in a more conceptual way. They don't necessarily have tests on meteorology, but we learn a lot about, like, okay, you see that cumulus cloud over there, what's going to happen in a few minutes? Okay, there's going to be a downdraft, it's going to get really windy, what does that mean for our sail plan? So it's really applied meteorology for the most part. We do have some large scale weather charts that come in through different technology that we have on board, and students will look at those and learn a little bit more about large scale forecasting. But it's a pretty interesting applied version of meteorology that you don't necessarily get in a university setting, at least not at like a undergraduate non-meteorology major level. Excuse me. And then students learn about sail theory, which is just physics, which is, super interesting, and people spend their whole lives learning how to trim sails perfectly, and that's not what happens on our ships. But we learn about, okay, if it's super windy, what sails are we going to set? If it's really light winds, what sails are we going to set? If we want to stay in one place, what sails will we take down, or what sails will we set? So yeah, there's a lot of science that happens out on deck, but most of our science happens in the lab. And so just so that you can have a conceptual understanding. I know that most people probably haven't spent time in a lab on a boat. It's a little bit different than a lab that you would see in a school or at a university. So on the left-hand side, we have our science deck, and you can see I'm the one in the pink hat, and then that's my student Karen on the left. And we were deploying a free CTD. I'll talk about what a CTD is in a second, but you can also kind of see that gray frame that's just kind of where my head is, right behind me. And basically, the winch, which is the center picture, is holding that instrument in the air, and then it's led through that frame that you can see, that aluminum frame in the background. And we're able to deploy a lot of instruments off of our science deck. And so even though it's technically part of the deck, it's not indoors, it's not in a lab, that very much is the first step in all of our science is deploying stuff off the boat, getting the stuff back on board, and figuring out what data we can use from that process. And then on the right-hand side, I don't have very many pictures of our labs, but that's me with that same student, Karen. She is running, I think we're doing a phosphate run. And so I'm kind of watching over everyone, not doing much. That was during JWO phase. And so the students were sort of leading the way at that point. But you can see in the background, there's a bunch of tubes, there's some samples in the foreground. We've got some students on computers. So it very much is a working lab. It's just a small space where things move around a lot. And so once we collect our data, we spend a lot of time in the lab processing. And I'd say that I probably spend 80% of the time, my time on board in the lab on the computer, just processing data, getting things inputted, checking data, making sure that everything that we've done kind of lines up with common sense. Do these numbers make sense? Is this something that a student was seasick and they wrote down the wrong number, or is this right? So that's how I spend a lot of my time is in the lab. But the fun part is out on deck, using the winch and deploying gear. Okay, so you just saw me and Karen deploying that free CTD. And I'm going to talk right now about kind of the different types of science that we do and the instruments that we use to collect that data. So that free CTD stands for conductivity, temperature, and depth or density. And so conductivity is a proxy for salinity. And so if you have the temperature and the salinity of the water in the ocean, and you know sort of generally where you are in the world, you can know a lot about that water mass that you're in. Water mass is a pretty specific term. It has to do with the density of the water in any given part of the ocean. And it changes with depth as well as spatially throughout different oceans. And so the CTD alone is a really helpful piece of equipment. I'll scroll back for a second just in case you're not picturing it, but you can see it's pretty small and it's just kind of a tube. We have it in a frame to protect it. And then on the right here, or back on this slide, we have what's called a carousel. And this is still basically a CTD. It's just a CTD with a bunch of stuff added to it. And this is probably the most impressive piece, or I guess conglomerate of equipment that we have on board. That CTD tells us a lot about where we are. I mean, just putting that in the water can tell us about all the water masses that we're sailing over. But when we deploy the CTD with all this other gear on the carousel, we have the CTD itself, which tells kind of the computer, what the temperature and what the salinity of any, of the water as you're going down through the water column. And then we also have an AFM, an automated firing module. And so you can see that this carousel is surrounded by a bunch of what look to be like tubes, and they're actually bottles. And so when we send them down, they're open. And right now in this picture, we're retrieving the carousel, so they're all closed. But basically we can program the automated firing module, the AFM, to fire at specific depths. So we send this gear all the way to the bottom. It doesn't do much, but on the way back up, that's when the magic happens. The CTD talks to the AFM, and the AFM says, okay, we're at this depth, we're at this pressure, this is where you wanted to close, right? And the CTD says, yep. And then the AFM sends a magnetic pulse and it closes the bottle. And so we can have 12 distinct water samples from 12 distinct depths, and each Niskin bottle represents one of those depths. So when this really pretty strictly chemical oceanography instrument gets up on board, we can extract a lot of interesting data, like carbon data, so pH and alkalinity. We can take that water and process it for those variables, but we can also look at, okay, we have this water from this very specific depth. We can look at more physical, I guess, biological parameters like microplastics, like phytoplankton, like to some extent zooplankton. But we have just a discrete water mass from a given depth, which is just pretty amazing. And when I say depth, I'm talking to, over 1,000 meters. This isn't 10 feet deep. This is really, really deep in the ocean, deep enough to have some larger oceanographic, we can see some larger oceanographic trends, which is pretty cool. Some of the sensors that we can add to the carousel, so you're not going to be able to see any of these in this picture. They're relatively small. We kind of just stick them wherever they fit. But we have a PAR sensor. So our PAR sensor looks at photosynthetically active radiation, so basically light. We have a DO sensor, or a dissolved oxygen sensor, and that senses oxygen in the water column. We have a chlorophyll A fluorometer. So chlorophyll A is like a proxy for phytoplankton. So we can kind of know what phytoplankton communities look like at depth using this fluorometer. We have a CDOM, so a color dissolved organic matter sensor. So that tells us about the organic matter and detritus that's in the surrounding water column that might be blocking out light coming from the surface. And we have a transmissometer. So that looks at water clarity. And that sort of looks a little bit more at a mix of turbidity from, maybe if we're in shallower water, there might be some sediment that's gotten kicked up. So that tells us a little bit about water clarity. And so we can have any permutation of these sensors on the carousel at any given time that we want for, and depending on where we are, we might care a lot near shore about, chlorophyll A, because there's all this runoff, there's so many nutrients in the water near shore. So we might be interested in, particularly chlorophyll A. So we may add that sensor on, and then we might get out into the middle of Sargasso Sea and know that productivity is, fairly low, and we might not have any students who are particularly interested in chlorophyll A at that given point. So we might take that sensor off. So it's not, what's on the carousel is not stagnant. That can change at any given point, and it just depends on what the chief scientist and the students want to be looking at, and it's my job to make it happen. The other instrument that we have is our flow through system. So deploying the carousel, or the CTD, as you can probably guess, is a bit of a process. It involves getting the boat to a place. It involves stopping the boat most of the time. We could technically tow those things through the water, but we don't generally want to. And so we can only do this, as many times a day as we want to stop the boat and go through this production. So sometimes the carousel might be in the water for an hour and a half, and we can't really do much else when that's happening. But sometimes we want to still be collecting data, and we can't get data from the bottom of the ocean while we're sailing. It's not possible for us, but we can get data from the surface ocean through what's called our flow through system. So we have a hole in our hull. It's an intentional hole that pumps seawater through a set of tubes, just like in the background of that photo when I pointed out all that tubing, that was our flow through system. And we have sensors there as well. And the sensors are the same as what we can have on our carousel. And so we can have a steady stream every couple seconds of what the water that we're currently passing through is like with regard to these parameters. So it's pretty cool. We have a pretty wide suite of what we can collect. We're not always using all these sensors. So, generally we don't have the PAR sensor on the flow through. I don't think I've ever seen that, but we almost always have transmissometer data. We almost always have chlorophyll A data, and we almost always have CDOM data from our flow through system. So it's pretty cool, I think. The chemical oceanography is sort of where my interests lie the most, but most people, I would say, are more interested in our biological oceanography or our marine biology that we collect where at sea. And we do a lot of biology. We do a lot of biological oceanography, and we do a lot of, we spend a lot of time looking at microscopes, looking at phytoplankton and zooplankton. So this is a huge, huge part of what students are learning during their time at sea. But we have a bunch of different ways to collect biological oceanography data. The biggest one being our Newston net that we always deploy twice a day. So that's that right-hand photo. And we always put that in for half an hour, twice a day. And we tow it at 2 knots. So we're getting 1 nautical mile of coverage twice a day throughout every single cruise track. And because of that particular tow, we actually have a really unique set of microplastics data that goes back almost 40 years. We also tow, or we don't tow phytoplankton nets, but we can put a phytoplankton net over while the boat is stationary. It's a pretty fine mesh. So if we were to tow it, we would likely rip it. And once in a while, we might have a student who's interested in bacteria. And so we have the capabilities to culture for bacteria on board as well. Everybody loves marine biology. We're not necessarily outfitted to contribute to the larger research community when it comes to marine biology, but we certainly experience it in a really up close way. So on the left, we have an albatross. I took this photo when it was just sitting, watching us deploy some gear in New Zealand. And it's pretty crazy that you're able to get this close to an albatross. So some of our students choose to study seabirds or floating plastic. They take more of a qualitative approach and have people pay pretty close attention to what's happening around the ship. At the top of every hour, students go out on deck. So we'll have one student go out on deck with a clipboard, and they, for exactly 6 minutes, observe exactly what's happening around the ship with regard to seabirds, with regard to, in the Sargasso Sea, we would look for sargassum, plastic, sometimes bioluminescence even, marine megafauna, so turtles, dolphins, whales, and depending where we are, different ratios of those things are present and make for interesting data. But we do kind of include that more qualitative and interesting aspect, interesting in the sense that it's interesting to the observer. And that's kind of what students expect when they come to sea. And it's a cool way for them to slow down and go on deck and see some interesting things, even if the data isn't necessarily our most accurate. We also have a hydrophone on board, which we, again, just use sort of for fun. When we're at Stellwagen Bank, we'll always pull out the hydrophone to try to hear some whales, but it's not generally used in student projects. We also have the capabilities to do some physical oceanographic research while we're on board. We have an ADCP, so an acoustic Doppler current profiler. So that tells us about the currents that are below our ship's hull at a variety of depths. This transducer is kind of a big kid toy, as well as the one below it, the Chirp. They both kind of are almost too complicated, the data that they spit out for a lot of student projects, just because it's a constant flow of a lot of data. It's big data. It's hard to work with on laptops, but we always have those running. So our ADCP is looking at currents, and our Chirp is looking at the bathymetry underneath the ship. So we always know what the sediment underneath the ship. Well, if we're in shallow waters, we can know what the sediment looks like and what the layering is in that sediment. If we're in deep waters, we can just kind of get a pretty vague idea of how deep the ocean that we're in is. If we're in 4,000 meters of water, we don't have a high definition picture of the bathymetry, but we do know, okay, how deep is the water that we're in. And so both of these use some technology that's pretty on par with what research vessels use. And so this is information that, if someone at Hui was looking for information from us, we could easily send them these files, whereas our 6-minute ops from students aren't necessarily something that we would send to an outside scientist. And we do some geological oceanography. This is a picture of me and one of my students, Lucia. We had just done a shipwreck, and I dropped the bucket, and it got all the mud from the bottom of Menemsha Bight off of Martha's Vineyard, got all over her, and she was a really good sport about it. But we can send basically this pretty scary claw down to the bottom of the ocean. We get it Once we get it rigged and it's ready to go, nobody puts their fingers near it. And then we basically deploy it at a pretty fast speed. It slams into the bottom of the ocean and we get a big bucket of mud. So there's no stratification for the most part, but it's a cool way to look at what organisms might be down there, what sort of sediment we're looking at, and we can sieve this and see where we're at as far as sediment goes. It's not a huge part of our research plan most of the time, just because we're not generally in waters shallow enough to do this. But generally at the beginning of the cruise track, we'll do a couple of these, and wherever we're allowed to, often in the Caribbean we are, and in the South Pacific, we aren't generally given clearance to do shipwrecks. So the different boats sort of do different amounts of sediment data, just depending on what the countries that we're sailing through are okay with. We have the capabilities to do gravity cores on both boats, so that would allow us to see some sediment stratification. I personally haven't done one of these, and they're deployments that are kind of held for specific students who really want to look at sediment stratification, or if we have some sort of particular goal for that cruise track that we really want to get a gravity core in, just because it's really like dropping an anchor using our hydrographic wire. It's a really big deal. It's a really heavy thing. It's if we're in rolling seas at all, it's not possible. But we do potentially have the capabilities to do a gravity core, which is pretty cool. I'd like to see one at some point. And I've mentioned student projects a bunch, but basically while students are on their shore component, they pick a couple of parameters that they might be interested in. So I looked at pH and alkalinity. So I was looking at like carbonate chemistry when I was a student, but we have students looking at all different parameters and how they relate to each other. And so mine, you would kind of, pH and alkalinity are just traditionally linked, and it's unsurprising that someone would look at both of those at one time. But we have students who look at microplastics and sargassum. We have students who look at chlorophyll concentrations and the physical oceanography of a region. So students can take a really creative approach to what parameters they particularly are interested in. And then they can decide whether they want to just look at those trends spatially, so throughout our cruise track, if they want to look at temporal data, so if they want to look at data from our cruises through that same oceanographic area, that same water mass from previous years, or even look at data even further back, so look at other organizations' data. It just kind of depends on how science focused that particular student and that particular program are. But students can really get into the weeds. They might be looking at like our chirp data or our ADCP data, which is pretty impressive and very much kind of university level upper division science. Or they might be using those 6-minute obs to give us some information about what seabirds we saw and where we saw them. And both of those are super legitimate, and they fit into our experiential education model. But yeah, we see both of those. And then my job as an assistant scientist, like most of my job, like I said, is deploying the gear and teaching students how to deploy the gear, but I also help mentor particular projects. So I generally get more of the chemical oceanography students. I take them under my wing and mentor them, just because that's what I feel the most comfortable teaching, and we want to give the best possible mentorship that we can. And then at the end of the trip, students give a pretty incredible 15-minute presentation at sea in rolling seas with a couple whiteboards and a friend holding it up. And they tend to be really interesting, even as someone who might have mentored that project. It's pretty amazing what students can come up with after being at sea and writing their project while seasick, and their only presentation method being a whiteboard. They don't have any way to really show anything super technical. They're not necessarily able to do what you'd be able to do at like a national conference, but the data that they convey is pretty impressive. So that's one of my favorite parts of the trip. And I will leave it there. I think I ended up talking for longer than I meant to anyway. So if people have questions, I know this is like my whole life and this is what I do constantly. So I might have left out some really big picture thing and you're just confused about what I was even talking about when I mentioned something, or if you have specific questions about specific parameters that we look at in science, I'm open to that as well. But thanks for listening.
This is great. If you could stop sharing your screen and so we could get our gallery up of folks, and maybe we'll be lucky. Feel free to show yourselves in the video, and we'll hope that the connection still works. So do we have any questions from any of you? Okay, Patrick, unmute. Good.
I just had a quick question regarding actually, like, how do I say this? Marine biology at like deep sea levels. Are you able to do any like deep sea animal stuff like that?
Yeah. So in the deep sea, kind of what we're able to do is we have meter nets. So there was a picture of me with like a pretty big net on deck, and we can actually deploy that using that hydro wire. So it can go even deeper than our chemical oceanography instruments can, just because, you know, a net isn't rated to any particular depth. So we can send that as deep as we want, and we can tow that for as long as we want. So we are able to collect some pretty cool stuff. I've caught like heteropods, which are really cool marine snails that they generally don't do super well once we bring them up to the surface just because of the pressure difference. But for a little while, they look like elephants, and they have a really large, they're really sparsely populated. So it's pretty cool that we're able to see things like that. But yeah, small things we can see at a pretty great depth. We don't necessarily have the ability to look at like communities of larger organisms at depth. So like, I don't know, some of the interesting things in like Blue Planet, like we're not looking at that yet. Who knows, someday maybe. But yeah, nets and zooplankton are definitely part of our curriculum.
Good. Any other questions? Okay, I'll butt in. I have 3 questions, and they all have to do with records. What was the hottest temperature water you ever sampled?
Ooh, I would say in the, well, so we usually sample in, our science stuff is in Celsius. We have sampled some pretty high temperatures when we were going through the Gulf Stream, so above 35 Celsius. But even off the coast of Massachusetts, with the Hui MIT joint program, when we sailed with them a couple summers ago, we went in search of a warm water blob, and we found it. And it was, I think that was the most surprisingly warm, just because it was in a pretty temperate environment. I don't specifically remember what the temperature is when I sailed in French Polynesia, because I didn't.
Yeah, I'd imagine that was pretty warm.
Pretty warm, but I don't specifically remember.
Okay. Second question. What are the deepest samples that you were able to obtain? How deep?
Well, at the end of a cruise, we have to do some maintenance on our wire. And so that's when we always kind of run whatever instruments we have on our carousel as deep as we possibly can go. So probably like 1,500 meters, maybe. But that happens pretty consistently, you know? We don't necessarily go super deep for any particular reason. We kind of stick within the ranges that we always, I don't know, go with.
Okay. And this is just this is a side question. Did you ever sample the Atlantic rise? What is it called? The Mid-Atlantic Ridge?
No, I don't think I've gone far enough east, question mark.
Yeah, it's like halfway.
Yeah. I think I've always been further inland than that.
Okay.
Yeah. But SCA has done transatlantic voyages in the past, so other people have, just not me personally.
Because that would have some volcanic activity associated with it. That would be Okay, and then this is a sailing question. What were the highest winds that you've ever had to deal with?
So I'm a really, really good person to ask that question. My student trip was actually we had the highest winds ever recorded on any SEA voyage ever. We ended up being in a, not in an ocean, not in a cyclone, but we were avoiding a cyclone and ended up finding some other really crazy weather. But we were in winds of over 90 knots, which is over 100 miles an hour hurricane strength winds, 25 to 30-foot seas.
Oh my God.
Yeah.
And I bet everybody got seasick.
At that point, we were pretty used to being at sea, and the professional crew were so focused on sailing that I don't think they even had time. And the rest of us had been properly medicated. We knew that it was coming. So that doesn't really, we felt a lot of things, but seasickness wasn't necessarily top of the list, which is kind of strange.
Yep.
But we had already been at sea for a few weeks, so we were kind of acclimatized.
Neat. Well, I can imagine you've had adventure after adventure on the seas, but you've also been posting on your Facebook page pictures from ashore. You spent some time ashore where you saw a lot of whales and otters and
Oh yeah, that was a different job. I worked in the fishing industry in Southeast Alaska this summer just to try something different in COVID times when we couldn't have students. Yeah, that's a beautiful part of the world I would highly recommend, but we don't go there on our boats. I wish, maybe someday.
That's wonderful. I've run out of questions. Anybody else have any questions? Okay. Well, you've made us all very jealous.
Oh, not the goal.
Well, made me jealous, that's for sure. I wish I could just be like a hair bobble as you go do all your things.
Absolutely. Well, a lot of our participants were high school age, so if any of them are interested, I'm happy to give my contact information. And if they're ever interested in doing one of our high school programs or one of our semester programs, we would very much welcome them.
Okay. Well, that's fabulous. Thrilled to have had you come aboard here.
Thank you so much for having me. It was great to share.
Okay. I have it recording, and so I will get it onto the YouTube channel and send the posting around.
Great.
Okay.
Thank you so much.
Yes.
Have a good one. Stay warm.
Okay. Thanks.
Thank you.